A very good morning, dear children. This is Brother Frank giving you the physics classes. Before I begin this day, I would like to appreciate the children who have done well in the Google Forms. That's Siddharth, Arun, Jayashri, Catherine, Karen, and Madhyalagan. They have scored 10 out of 10. My sincere appreciations to you, dear children, and the second place goes to Valerian, 9 out of 10, and Nityanandan, Shirley, Jackson, Lokesh, and Darshini. They are scoring 8 out of 10. Great, you guys are doing very well. I am very happy about that. And nice meeting you after the Zoom classes we had, and that was really a good interactive session. You have asked many doubts, and I'm very happy that you have asked doubts and I clarified those things. I hope we have completed the first chapter completely. I have taken nearly 2 months, but only 7 to 8 classes from June to August. I have completed so 8 to 9 classes and have thoroughly completed the first chapter. Now I have written something on the board. You see, Google Classroom. What's it, Google Classroom? Just go to the Play Store and download this Google Classroom app. That is the code of our classroom physics class JMNQ7Q4. JMNQ7Q4, all lower cases. That means small letters. This is the Google Classroom code, and here I would give you some of the assignments and questions and materials, many things like that, because just the Google form, just 10 questions is not enough for us. So I will give you some assignments and I will ask you to do, and I will keep track, I will give grades, and all the internal marks I will give based on these assignments what you are doing, and based on the tests, Google form tests what you have done. Okay, in the Google form, I find one fellow who is doing some mischievous thing. He is giving some different answers, not giving name, and finding the answers, and after that submitting and getting marks. Dear chap, I appreciate your smartness, but you are not cheating me, you are cheating yourself. Okay, good. Now, we have done the first unit, right? The first unit, we have done some very important concepts like speed, velocity, distance, displacement, acceleration. So they are the very, very important concepts, and after that we moved on to equations of motion, graphical form, and three equations, and the problems we have solved according to those equations. So those are the very important fundamental points or the topics, ideas of the first unit. Now, from there, we are jumping into the second unit, that is force and laws of motion. From there we come. We are getting into the second unit, that is called force and laws of motion. Okay, now I am getting into the topic right now. So, we saw there is motion. Okay, there are only two states. One state is, okay, fine. One state is state of rest, and another state is state of motion. Okay, this is state of rest, this is state of motion. There are only two states for any object. It can be at rest and it can be in motion. There are only two states. So in the first unit we have seen it is an object is in motion in a straight line. So what are the equations of motion? what is the speed it is going, what is the acceleration, and how far it has moved, distance, displacement. All the things we have discussed clearly. Now, there is a very fundamental question that comes to our mind. This is in motion. Okay? Who causes this motion? Who is the cause of this motion? Is it simply moving? Or I am the cause of the motion? My hand is the cause of motion? What causes this motion? This is a very pertaining question. What causes this motion? Ultimately, we jump into today's topic, that is force. Force. Force is the one I am applying force. And force causes motion of this object, of this ball. Okay. So we are now getting from motion, we are getting into force. What causes motion? Okay. You can see a bullock cart. A bullock cart is moving. Who is moving? Who is giving that? What makes the bullock cart to move? Ultimately, it is a bullock. It is pulling the cart. Okay. Now that is pulling. Huh? Now consider this is a football, but this is not a football. Or else you can consider this as hockey. Actually, it's a hockey ball. Okay. What causes motion of this hockey ball? So this is a hockey stick. When somebody hits this, it is in motion. Okay, the force is applied by the hockey stick, and so the ball is in motion. And consider. Okay, you can consider this as a box. Okay, this as a box. It is at the state of rest. Now I am applying a force, and this is pushed, it's moved. So pushing is an effect of motion. Can we see motion? We cannot see motion, but we can see, but we cannot see the force. We can see only the effect of force. Okay, these are some of the effects of the force. Now, the ball is moving. It's the effect of the force I am applied. The box is moving, and you see the train is moving. All are the effect of the force. The bus is moving. The car is moving, and you are moving. Everyone is moving. That is not exactly a force, but we can see the effect of the force, that is movement. So, what causes movement? Ultimately, the force causes movement. Now, I am getting into the important topic of this unit, that is, I'm going to deal with two important topics today. One is balanced and unbalanced forces. The second topic would be first law of motion or law of inertia. Newton derived this, Newton's law of motion and inertia. These are the two important topics I am going to deal with you today. Now, what does the force do? The force, uh, it changes the velocity. It does two things. It does two things. Keep this in mind. It changes the velocity of the object, or it changes the direction of the object. How does it do? Now, if I apply more force, the velocity is increasing, right? When applying less force, the velocity is decreased. So, force can change the velocity of the object, and force can change the direction of the object. Okay, now I am coming to a very important part that you will guess right now. Now you see, force ball is coming in one direction. If there is a force, it can change into other direction. Okay, if there is a force, it will change into other direction. So force will change the velocity, the magnitude of the velocity, and it can change the direction. So you see, force has some value. It has a magnitude. And if I apply a force on this direction, ball will move only in this direction. If I apply a force in this direction, ball will go in this direction. If I apply a force in this direction, ball will come only in this direction. So force has the direction. It has a magnitude. It has a direction. Then what it is called? What it is called, my dear children, you should say it has a magnitude and it has direction. That is, it is a scalar quantity. Sorry, I'm sorry, it's a vector quantity. Vector quantity means it has both the magnitude and direction. Now I have given brief introduction of what is force and what causes the motion. Okay. When it comes to force, we are going to see two systems. One system is called balanced system. Another system is called unbalanced system. We are going to learn two systems of force to understand how the force is acted upon an object. So first we are going to see a balanced system. A balanced system is what? A net force acting on an object is zero because there is no movement. It is balanced. Why it is balanced? You see, this is a block. X is pulling in this direction. Y is pulling at that direction. If both the forces are equal, where will the block move? For example, this is a block. Okay, X is pulling it one direction, Y is pulling it another direction. If X and Y are pulling at the same magnitude, will there be any movement? Will there be any movement? Will it go this side or will it go that side? Both are equal magnitude. Both are pulling at equal force. Will it move? It will not move. This is called a balanced system. A balanced force system, object will not move. There is no movement at all. But when there will be a movement. So the net force, the resultant force or the net force acting on an object is zero. It's a balanced system. The object will not move. It will not move at all. Now, when there is a movement, there will be a movement only when one force is more than the other force. The force on the one side is greater than the force on the other side. For example, I take my right hand as X, my left hand as Y. So, when my right hand, when X is pulling, imagine my right hand as X, person X. So, the X person is very hefty, is a bodybuilder. Now, on the other side is a very lean, thin fellow. So, both are pulling the rope. Imagine, have you seen tug of war during the period of Onam and during Pongal celebrations? They used to play tug of war. That means a rope will be in between, and some 10 members on the other one side and another 10 members on the other side. They will pull the rope. Where will the ultimately where will the rope move? It will move on the side who is stronger, right? So consider person X. Consider that person is very hefty. So he's pulling. When he's pulling, you see the force on the right hand side is high, greater than the left hand side. So ultimately the block moves. So movement has taken place in the condition where there is where the forces are in unbalanced state. It is not balanced because this side has more force. Ultimately, this is pulling. Now, he has gained some weight and he has done some exercises and he has done some really, he has eaten well. And now, this time, why is pulling? He exerts more force on this side and ultimately the box or the ball is moving on the other side. So, when there is an unbalanced condition, when the resultant force is on the one side is greater than the other side, the object moves, or else it will be in the state of rest. Now we are coming into that point, that is Newton's first law of motion. Before getting into Newton's first law of motion, I would like you to understand, for the balanced system, there is no movement at all because net or the resultant force is zero. So it is in the state of rest. But for any movement to take place, the system has to be in unbalanced state. Okay, unbalanced state means one side or on the it experiences force on the one side, so it moves. For example, you can have an example of ball also. I am applying a force on this side, so it moves. So force is there on this side. On this side, there is no force, so it's moving. So it is an unbalanced state. Now it is in the state of rest. It's not at rest. Sometimes it moves. No, and now it is at rest. See, both the forces acting, or all the forces acting, are equal, so it doesn't move. It's a balanced system. So what you have to understand is, balanced system there is no movement at all, but in an unbalanced system there is a movement. There is a movement. Okay, motion takes place only in the unbalanced state. Yes. What is now? For example, now we are getting into another important idea of this balanced and unbalanced forces is, are you able to see, ma? Friction. Friction. Have you heard this word friction? Friction is a very important idea or a word that comes under when it comes to motion. Okay, friction is a resistance that is offered by the surface of the object. Okay, uh, I am getting a phone. Now, friction means it is a resistance that is offered by the surface of the object. For example, this is a rough object, so it has more friction. If the object is very smart and smooth, the friction is less. That means uh, for a for this is a hockey ball, so it moves like this. But if it is a rubber ball, how would be the how would be the surface of the rubber ball? It's very soft, you know. It's very soft. So it moves very fast. But this is a hockey ball, no? It cannot move very fast because the resistance offered, because the surface is very rough, it exerts a resistance in the surface. For example, this is a consider this is almost a smooth surface. But if I put this in the ground, will it move like this? Will it move this fast? It will not move because the resistance of the ground is very high. Because at this there are sand, there are stones, it will offer resistance. Resistance means how to say in English, right? In Tamil, the tadai for the movement. Okay, it is an opposition for the moment. It will move like very fast. If the body is very smooth, if the land is very smooth, it will go on and on. It will not stop at all. In a zero resistance or a zero friction condition, ball will never stop because there is no resistance, no? Because there is zero friction, no resistance. Ball will never stop. It will go on and on. But why it is stopping? Why it is stopping? Because the resistance is offered by this ground. The resistance is offered by this surface. Resistance means a force against the movement, that is called resistance. Okay, who is here applying that resistance? That is offered by the surface, that is offered by this surface, that is offered by this surface. It's a wonderful example, I could say. How we are walking. If there is no friction, we cannot walk. We will just fall down. We will just. For example, now I get a good example. You will be playing that swing, no, or the circus. Usually the circus in the playground. Okay, in the playground we go up. You go up on the on the ladder and you come down. When you come down, will there be resistance? The resistance will be very less for this movement because this is frictionless. This place is frictionless. So the movement is very fast. There is no friction. Will the surface be rough? No, not at all. The surface is very smooth. So that movement is very fast. You come very fast. But if the surface is hard and rough, can you move fast? No. So friction is a very, very important concept that you should know. It's an important point. Friction. Friction means the resistance offered by the surface. You might know that this example of the joints. For example, if you oil those joints, if you're riding a bicycle or if you're riding a motorbike, you will oil those joints. Why you do oil those joints? Oil is a perfect lubricant that will reduce the friction. Okay. Now I am coming into the point. Uh, I said no. We are walking. We are walking because there is a frictional force applied from the ground, or else we cannot walk. Okay, if there is no frictional force, you will simply can you walk on this road, on this slope? You will fall down because there is no friction. But you can walk on the road, on the normal road, on the soil, on the sand. You can walk because that road or sand offers some resistance, some friction, so that you are walking. Okay, here you cannot walk. So there are many, many, many examples like that. Um, what would be easy for you, to walk on the road or to walk on the beach? What would be easy for you? Maybe walking at the beach will be giving a lot of joy and satisfaction, not on the road. But what will be easy? To walk on the road is easy because it is a smooth surface. Friction is less. Movement is fast. You can run fast. Or else I can ask you, where you will run fast? On the road or on the beach? On the beach, you cannot run fast because that sand offers more resistance. Resistance to the movement. நம்ம நகர்வதை தடுப்பது, அதுதான் resistance. That is called friction. In the So I am taking so much time to explain this point, that is friction, right? Okay. Now this is a box. Consider this is a box. Now I'm applying a force like this. The box is not moving. Why it is not moving? Because the frictional force, the applied force, is less than the frictional force. there is some friction. You see, under the bottom of the object and on the surface of the object that is placed, there is some friction. So the object doesn't move. Now I am applying. It's not moving. When the force applied by me is more than the frictional force, then the body moves. Until then, the body experiences a frictional force opposite to the force of my action. Another very good example, you all might have having a bicycle at home. Okay, you might have enjoyed cycling in a straight road, in a straight road, not an inclined road, in a straight road. Okay, when you pedal only you can move, right? If you pedal for once or twice, will it move for 1 kilometer or 2 kilometers? Why? Because the tires and the road offer some resistance after applying a force. The force is applied, the cycle is moving for some distance, after that it doesn't move because the resistance that is offered by the road and the cycle tires makes the movement slower and ultimately it comes to rest. It comes to rest. And after you pedaling, after the cycle moves, you are moving. So this is a very good example for bicycle, beach road, and this example and the example from the park, the circus from the slope or the circus from the park. There are four very good examples, real-time examples. What we are seeing, what we are experiencing in our day-to-day life is a perfect example for friction and force. I hope you have now got a clear idea about the friction and force. Now, to accelerate any object, to move any object, you need an unbalanced force. I said balanced force, no movement whatsoever. But for a movement to take place, you need an unbalanced force. Okay. So acceleration the motion of the object. If you want to move the object with a particular acceleration, you need an unbalanced force. That means you have to apply a force on one side. There should not be a force on the other side. So that there is an unbalance created. And with that unbalance, the body is moving. It is accelerating. I am getting into a more technical term. It's not just moving, it's accelerating. What is accelerating? Ultimately, it is a change of position, it is a change of velocity. So it is accelerating. Okay. So I am going to solve some problems. Uh, Under solving good number of problems, the theory or the lecture, understanding the concepts have no use at all unless you solve the problem. So solving problems, and for this chapter, it's a very easy thing. It does not contain like the equations of motion. We had three equations, no? It doesn't have those kind of big formulas. Very, very easy formulas and easy equations. Just arithmetics. You need not to remember those formulas. So, the Google form contains problems. All the problems are very easy, just arithmetics. Just arithmetics. If you know the common sense and arithmetics, you can solve the problem. Okay, now the the Google form of today contains many such problems like this. Find out the net force acting on the object. Net force acting on the object. So, whenever we shall have some convention, what convention? The force acting on the right is positive. The force acting on the left is negative. Okay, this convention we remember. Always we remember that. Now this is a block. Force acting on the right is 22 units. I have mentioned unit. But what is the unit of force that I will teach you when I teach the first law of motion? But it's good to put units teach you to better understand with better clarity. Okay, unit is not right. Newton, force, the unit of force is Newton and force is a vector quantity. Why? Why? Because it has both magnitude and direction. Okay, Newton and Newton. We all have is Newton. What is Newton? That I will teach you. Okay, don't. Now, 22 Newton on the right hand side and 17 Newton and 10 Newton on the left hand side. What is the net or resultant force? Very easy one, damn easy. Because you know the object is at rest, it is not moving. Okay. When it is at rest, ultimately net force is zero. Net force is zero means what? Right hand side is equal to left hand side. So always remember this equation. What is this equation? Force on the right plus minus force on the left is equal to net force. Net force or resultant force, that is equal to zero. That is equal to zero in a balanced system, not in an unbalanced system. So force on the right. What is the force on the right? Force on the right, 22. Yes. Force on the left. So for you it is right, for me it is left. Okay, now you understand. This is right. Always this is right. Okay, that is left. Hmm? For you, for me and you it will change. Okay, forces on the right hand side. Okay, for me it's left, but for you it's right. 27, 17 plus 10, 27. Forces on the left, minus 22, is equal to 0. What is the net force? What is the net force? So 27 minus 22 is equal to net force. That is equal to 5. 5 Newton. 5 Newton is a net force or resultant force that is acting on a body. Okay. So, what is this is damn easy. What is there? Nothing is there. This is a balance. When we go in balance system means net force is 0. Find the value of x if the system is a balanced system. Okay, find the value of x. Simple. Balanced system means force Fr minus Fl is equal to Nf. Okay, simple form. What is Fr? 7. Force on the right. Force is on the right. Plus 4x minus 3 plus 10. Okay, this is Fr on the right hand side. What is Fl on the left hand side? This is 22. That is equal to net force. When you solve, okay, 17. 10 plus 7, 17 minus 3, 14. Okay, 17 minus 14. 14 minus 22. What is that? Minus 22. 14 minus 22, 8. Minus 8. 4x is minus 8 is equal to 0 because it is a balanced system. So 4x is equal to 8, x is equal to 2. Find the value of x if it is a balanced system. Very easy. That's all. Nothing. So I have solved one normal problem, one balanced. Now I will solve one unbalanced problem. Okay. Unbalanced system. This is the question. Find the value of x. If the system is an unbalanced system, find the value of x. Now what is the question? If the net force equal to 10 Newton that is applied on the left, okay, applied on the left, 10 Newton, 10 units. Okay, if 10 units is applied, the net force applied on the left, towards the left, what would be the value of x? This is the question. Balanced system means equal to 0. Unbalanced system means you are equating to 10. That's all. For example, what is the equation? Forces on the right minus forces on the left, that is equal to net force. What are the forces on the right? 6 plus 5x plus 10 plus 15. What are the forces on the left? 7x minus 13, sorry, 3 on the left, that is equal to net force. What is the net force? 10 Newton or 10 units towards left. Left means the convention is minus. Right means the convention is plus. That's all. Simple. Convention is minus 10. With minus 10, you solve this equation, you will get the value of x is equal to 14. So due to the lack of time, I'm not solving this. Very easy, damn easy. Just arithmetics. Okay? Put x on one side and numbers on the other side, you will get the value of x. The point, very important point is for an unbalanced system, minus 10. If it's moving towards left, minus. If it's moving towards right,